The cost and time of 3D printing grow cubically with respect to an object's scale. To fabricate a large object, it has to be partitioned into smaller parts for printing and assembled later. We present a coarse-to-fine approach for cost-effective fabrication of large objects. An input 3D model is represented by a coarse interior polyhedron base and a fine exterior shell. The polyhedron base is produced by 2D laser cutting by assembling planar plates with well-designed joints. The exterior shell is fabricated by 3D printing and then attached to the bases. Our approach significantly reduces the fabrication cost and time. The assembled object can be repeatedly disassembled and reassembled, facilitating storage and transport. The fabricated object can stand by itself. To approximate a 3D shape using an inscribed convex polyhedron, we start with a simple cuboid. We optimize its vertex positions to maximize its volume while fixing its topology. Next, we modify the polyhedron's topology using planar cuts. Then, we iteratively optimize the geometry and topology of the polyhedron. Various constraints, such as assembly, aesthetics, symmetry, and balance, are enforced in the optimization. For the complex shape shown here, we segment it into a few quasi-convex components and approximate each component with one convex polyhedron. During the optimization iteration, we enforce one more constraint for two neighboring polyhedrons. We construct an interlocking laser-cut base from each optimized polyhedron. Our method iteratively explores polyhedral corners to create local interlocking groups with non-orthogonal joints, and links the groups into a network to construct a tightly connected laser-cut assembly. By using printed rods and screws, 3D printed shell parts are then attached onto the laser-cut bases. We assemble the laser-cut parts of a Max Planck model following a certain order. The parts interlock with one another through the designed joints, forming a steady assembly. Now, we assemble the other laser-cut base. We attach the 3D printed parts onto the bases and connect them using printed rods and screws. Lastly, we put the two part assembly together. After tightening the screws, we put the key part in the assembly. Here we show fabricated objects of varying shapes and sizes. Thank you.